Welcome to Brain Vision.
In this question, we are given a neutron. Starts off with energy E naught of 1 MeV. And we want to find how many collisions it takes to bring it to an energy of 0.04 eV. Now we are given that for each collision, the energy is halved, right? 1/2 of its kinetic energy is lost to the collision. So the energy at the nth collision, after n collision, will be equals to the original energy multiplied by half to the power of n. So in order to find what is the number of collisions when En is equals to 0.040, right, we have to do some manipulation, right? So what we do is we bring E naught over to the right hand side, get half to the power of n. We take the logarithm, natural log on both sides. The power is brought down. Right, and finally we divide ln half over to the right hand side and we evaluate the expression. Should get n to be equals to 24.58. Now this is the minimum number of collisions that is required, but we know that number of collisions should be an integer value, so we will need to round this up to about 25 collisions, right? A minimum of 25 collisions to bring it below 0.04 eV.